Hey gang, this video is to go over mirrors, converging and diverging. So we've done converging lenses and diverging lenses. Now we're doing converging mirrors and diverging mirrors. Typically what happens with a mirror is that if I stand in front of the mirror and I look at my toes, I know that the angle of incidence equals the angle of reflection, right? So mirrors reflect light. Okay, so this is what we call a planar mirror, plane mirror, meaning it's flat, not like plane like ordinary, but just a flat mirror. So the light reflects off at exactly the same angle. Well, what about converging and diverging mirrors? Okay, so a converging, let's do converging first. Converging mirrors are actually concave. That was the opposite for lenses, right? So a converging mirror is one that's like this. And I've got a focal point and I've got a center of curvature. Notice how with the mirrors, I don't have two focal points. There's nothing happening back here behind the mirror. So if I'm out here, here's my object out here. And I want to figure out where this object is going to be when I do this converging mirror. Light for a converging mirror. Oh, let me back up just a hair. What happens to all parallel rays? For converging mirrors, all rays parallel converge to the focal on the near side. So if I had a focal here, all rays parallel to the mirror are going to bounce right through the focal on the near side. All rays parallel to the principal axis converge to the focal on the near side. So that's like a converging mirror. It causes it to bounce back, but it bounces back focusing it to a point. So it's not like it's kind of like what a magnifying glass does, but magnifying glass is a lens. Converging mirror collects the light and focuses it to a point. Kind of like the mirror on the Hubble Space Telescope. It's converging as it's a big concave dish that collects light and focuses it back to a point. So all rays parallel converge to a focal on the near side. So here goes my ray. It's going to converge to a focal on the near side. Oh, I kind of missed, but I'm close. There you go. What else do I know? There's this thing called the center of curvature. Any ray through the center of curvature goes on forever. If I go through the center of curvature, this is a little bit different than lenses. Like lenses, we always use the middle of the lens. But for mirrors, we use the center of curvature. It's the center of the circle, as if the mirror were a full circle. And any ray through the center of curvature is going to hit at 90 degrees and bounce straight back. So here it goes, here it goes, here it goes. It's going to bounce straight back. Think about like spokes on a wheel. If I pass through the center of curvature, I'm going to hit it and come straight back, right? As if the wheel is my mirror. So any ray through the center of curvature comes straight back. So let's do that one in blue just so we can see it a little bit better. Come straight back at me. Because if I go through the center of curvature, I always hit the surface at 90 degrees. My third ray, I'll do it in green, goes through the focal. It's a reversal of the first and comes out parallel. And you can see right here, I have an upside down, inverted, real image. Why real? The light rays came together there. Inverted, well, it's upside down smaller. So how do I do the math for this? It's the exact same as the other formula. So if, again, DO is 60 centimeters, we'll keep using these numbers. And DO is 60. If the focal is 20 and the height is 40 centimeters, then I would use the exact same equation. And but this time I don't use negative F. For anything converging, you're going to use the positive focal. So 1 over F equals 1 over DO plus 1 over DI. So 1 over 20 equals 1 over 60. 60 centimeters being this distance, 20 centimeters being that distance, plus 1 over DI, and I should get 15. No, 30. And that's where this image is back past the focal. Notice how my magnification is going to be negative. Negative DI over DO. My mag is negative 30 over 60 or negative 0.5, which kind of makes sense because this guy is upside down and it's smaller. Beautiful. Perfect. I love it. So that's about where that image should be. So again, converging mirrors, all rays parallel, converge to a focal on the near side. Same equation for the thin lens formula, but I'm using it for mirrors. And I'm going to use a positive F because it's still a converging thing. Okay, it's a converging thing. So again, all rays parallel. For converging lenses, we converge to a focal on the far side. For converging mirrors, they converge to a focal on the near side. For a diverging lens, they diverge from a focal on the near side. Let's see what a diverging mirror does. So there's your converging concave mirror. If I have a diverging mirror, a diverging mirror is going the other way. You know what? It's interesting in your homework, you might see a diverging mirror because they put the object over here. Well, if I put the object over here, I'm now approaching a convex mirror. If I'm looking at it from this side, it's convex. If I look at it from this side, it's concave. So the mirror could be mirrory on both sides. It just depends on which side you're approaching from, right? So now if I were to approach from this side, I have what we call a diverging mirror. And for diverging mirrors, all rays parallel, diverge from the focal on the far side. Straight away, straight away. Remember, the light can't pass through the mirror. It's a mirror, right? It's not like a two-way mirror. The light is actually going to move away from that mirror, but it doesn't move away randomly. It moves away from the focal on the far side. So let's do an example here. What if I have my object out here? We'll do again 60 centimeters for my distance to the object. We're going to go along the principal axis. We're going to draw our mirror. The focal is here. Now, the focal is interesting for a mirror. There's not a focal on both sides because the mirror is only curved one way, right? So like the focal is always on the inner side of the curvature. I do have the center of curvature over here. With converging mirrors, it's not so much, you know, a diverging lens goes like this or converging lens goes like this. A converging mirror or diverging is just looking at it from one side or the other, as long as it's mirrored on both sides. Okay, I'm going to give my same focal of 20. But now I've got what we call a diverging mirror, which is also convex. So those might be test questions too. Converging lens, convex. Converging mirror, concave. Diverging lens, concave. Diverging mirror, convex. What happens here? The first ray goes parallel. And it goes not randomly away up to the left. It goes exactly away from that near. I draw two dots and use a straight edge, straight away like that. Remember that center of curvature ray a minute ago? The center of curvature ray. If I just go through the top, the center of curvature in the mirror, I can kind of bounce back and forth forever. Same idea. Center of curvature is here. Top of the, let's do this one in yellow. Center of curvature here. If I take a straight edge and go straight towards that center of curvature, I can kind of go on forever. Now, realistically, the light ray didn't go back here. I get that, right? It didn't go into the mirror. So maybe I should do dashed over there. The light ray would go to the mirror, and because it hits at 90 degrees, it comes straight back at me. So, okay. So the red ray went right parallel and then went away. The yellow ray goes towards the center of curvature and comes right back at me. The third ray is a little bit tricky. We'll do it in black. The third ray goes towards the far focal, but comes out parallel. Yikes. So what you notice with the mirror then, just like a diverging lens, what you notice with the mirror is that this black ray down here, this will make it green coming back. This green ray and this red ray, they don't seem to come together. right? The red coming back, the green coming back, and the black, they're spreading apart. Well, what do we do with diverging lenses when they spread apart? When things spread apart like this over here, that means we're going to have to trace back. I'm going to trace this one back into negative space. This one back, and where's the black one? I'm going to trace the black one back. And you can see my image is an upright little image right there. You see this in like the mirror in your on the rearview mirror of your car, maybe, or on the side mirrors, those little round mirrors. You see these little round mirrors like in CVS or Walgreens up in the corners. Those round mirrors, when you look at them, you can see a lot of stuff, but everything looks small and upright. That's exactly what you're seeing here. Imagine kind of that round spherical mirror that's kind of like a ball, and it's up in the corner of like the CVS or the Walgreens or around a corner to where you can see. And you see a lot of things, but everything you see is small and upright. So that's what a diverging mirror is creating. Okay. The converging mirror is almost more like your vanity mirror that you're holding up close to you. And if you get really close, you see a big image. We can do that one too. But here, let me do the math. So once again, if I do the math, 1 over f equals 1 over do plus 1 over di. But because it's diverging, once again, I've got to make the f negative. Let's see what that means here. 1 over negative 20 equals 1 over 60 plus 1 over di. Here now, negative 1 over 20 is 3 over 60 minus 4 over 60. I'm going to get a di of negative 15. Now, what does that mean? Well, that's confusing because with the lens, that meant it was on the right side, but I'm on the right side here. That negative means it's, here's what the negative means for me. It means it's where the image shouldn't be. This is a mirror. I'm on this side of the mirror. Should I see myself like in the mirror? Is there actually an image in the mirror? No. The light should reflect out. When I hit a mirror like this, the light reflects back. If the light reflects on its own, it's creating a real image here. That's a real image. The light rays are actually doing what they should be doing. Here, I'm kind of seeing myself like back in the mirror. Well, there's nothing in that space. That's that virtual image. If the rays aren't converging on their own and I have to trace backwards, whether that's the left or the right, that means it's a virtual image. It means it's a virtual image, okay? That's that negative di. Negative di means it's going to be a virtual image. Watch again what happens to my mag. My mag is always negative di over do. So once again, negative 15 over 60 means a positive 0.25. And that's okay, because if you look at my image, it's upright. It's about a quarter of the size of the original one. Beautiful. So that's converging and diverging mirrors. Hopefully that helps kind of wrap up this chapter. We'll have a few days to review before the test. Test will be on day 3 of the week after next. That's a little bit confusing. What day is it today? So that would be 12th, 19, 26, I guess. So we've got some time, but this should help you with mirrors converging and diverging. There's one other one I might do real quick since I might have time. What if I was doing converging and I'm inside the focal? Center of curvature. What if I'm doing converging and I'm inside the focal, like right here? What about this one? Parallel through the focal. 1. Where's that center of curvature? Back here. Always straight through the center of curvature. Comes right back at me because it hits at 90 degrees, right back at me. The third ray was tricky. It was through the near focal. Let's do this one in green, but out parallel. Well, man, look, this one, and this one, they don't come together. So guess what I'm going to do? Just like converging lenses when you're inside the focal. Remember converging lenses, that tough one? These, if I trace them back, they should, I missed that blue one a little bit, didn't I? Come together right back in here. This is the vanity mirror. When you get right up on your vanity mirror, you see yourself huge, but you're in there. That's what you're seeing. Cool? All right. Good luck, and I'll see you guys next week. Violet gives you a thumbs up.